All right, so now that we've got our properties for our PLC set up correctly, it's time to get our PLC tags made. So on the project tree on the left-hand side, we're going to go ahead and expand the PLC tag section. And that will show us, we've got the show all tags option, add new tag table, and the default tag table. If we just go to the default tag table for right now, you'll see a new screen pop up here on the right hand side. And you will see that all of the tags that we see are from enabling the system and clock memory. Now, we didn't talk about what that does, but what the clock bytes are is it's a bit, one single 0 or 1, that will go true at a very specific frequency based on its name. So here you can see it at 10 hertz. This is going to go true, false at 10 times per second. The clock 5 will be 5 times per second, etc., etc. So those are very useful in your code for all sorts of things. But that's what those clocks are. That's why they are so important to us. Now, I like to keep my tags organized. So over here on the left-hand side, I'm going to go ahead and click the Add New Tag Table button. And I'm going to create 3 new tag tables right off the bat. Just click it 3 times. And my first one, I'm going to rename to Inputs. My next one will be Outputs. And my last one will be Memory. Now, this is how I like to do it to try to keep things organized. You are welcome to do it in whatever way that you personally like to do. But this is how I do it, and it makes a lot of sense. As my programs get more and more complex, I actually add more tag tables. I have different tag tables depending on the data type that we are using, which we will come back to in a minute. Now that we have those tag tables created, I'm going to go ahead into my input one. How do I know which tag table I'm in? Because just because you clicked on it doesn't mean it's changed you. Up here at the top in the blue bar, there is something that says inputs. That is the best way to know which tag table you're in. So if I come down here and I click on memory once, notice that we're still in inputs. You've got to double click. The other thing that I like to point out to you is at the bottom of the screen, all the way down here at the bottom, we kind of have a taskbar like Windows would have with all the different things that we have open. So here's the memory tag table, here's the inputs tag table, the default tag table we open, and kind of the home screen. But as you open more things, you'll get more tabs down here going. It is nice to close those every once in a while, so I just like to point that one out. Now, under the input ones, we're going to go ahead and I'm going to say we have a start button. So this is me actually figuring out what inputs my PLC are going to have for whatever project it is. For the purposes of this, I'm going to say we're going to use those three button block that was in the picture that was in that original video. If you haven't watched that, make sure you go back to the beginning of this playlist. That talks about the PLC trainer boards that we'll be using this semester. But I'm going to be using that. So I'm going to call the start button. It's going to be my green one. I'm going to put green in parentheses just so I remember. And then I'm going to have a stop button, which is going to be red. And then I'm going to have a process button. And that's going to be my yellow button. Now, it might be a good habit for you to actually say button in front of this. So that way when you're looking for one but you don't remember your tag names, if you're like, it's a button, you can just start typing button in and it will show you all of the buttons that you have. So the tag names is very important what you are naming them. Luckily, the Siemens software here does allow spaces in names. Some PL software does not allow spaces. You can't have that. So capitalization and things like that becomes very important. Traditionally, you can use underscores, but people don't like underscores. So when I'm doing tagging, if I can't use spaces, I just capitalize every new word, and it just makes reading it so much easier. But anyway, we've got these 3 buttons created, and notice that we have a address column over here. It's the third column, yep. It's the third column, and it starts with I0.0, then I0.1, and then I0.2, all right? And it will continue going up, all right? And if we wanted to keep making things, and I'm just going to call this limit 1, so we just have a new input, so limit 1. And that becomes I0.3. So I stands for input. If we actually click the little drop-down arrow that's right there to the right of the address, it will allow us to input more information. So here you can say our operand identifier. If we look at what our options are, we have I, Q, and M. Inputs are I, outputs are Q. Why Q? Well, I think they didn't want to get you confused between 0 and O. So they decided to use Q, which still looks like an O, but is very obvious that it's not a 0. And then M would be memory. Then we have our address and our bit number. And you may be a little confused. What's the difference there? Well, if we would go back to our picture here, and we're looking at just our inputs, remember our inputs start here and go this way. All right, so so far, this would be our start button would be 0, stop would be 1, and our process would be this, and then 3 would be our limit. So the bit number, all right, let me click back on that. The address, that is the section that we're using. Now, this is a little confusing because on the PLC, it is written as A and B. I hate that they went that way. So you can see, back to pen. You can see we have an A section and a B section. And the reason it's labeled A and B on the PLC is because you can pick the numbers. It defaults to A being equal to 0 for an address and B being equal to 1. So that is something very important. You can go change them. You could make them 5 and 6 or 8 and 9. Or it's always going to be A and 1 then the next one. But you could pick those. There is no real reason to change those. So I've never changed them in my life of PLC programming. But for our purposes, we're not going to be changing them. Anyway, then you can see we have 0 through 7. So if you go past input 7 in the software, so right now we are at input 3, and I'm going to cheat here. If we click on the little square in the bottom corner, you see we get a little plus sign that shows up. Just like in Excel, if we click and drag that, it will actually copy it. All right, I'm just going to copy a whole bunch of those. Notice it increments the name limit 1, 2, 3, 4, 5. Notice after I0.7, we come to 1.0. And then 1.1, 1.2, 1.3. All right, so it does increment those addresses as well. Now, the data type that we are using in this case is Boolean. All right, B-O-O-L, and that just means true or false, 0 or 1, on or off, true or false, on or off, whatever. It's something that has two states. It's either a 0 or a 1. That's basically all it can be. We'll get into different data types later in the video series. But for our purposes of most of the beginning of this semester, we are going to start with the Boolean data type. Now, if you were using a different piece type of software, say Allen Bradley, you would actually have to create a timer data type, where in Siemens, they have a data block that the timer creates. So it's done a little bit differently. So we're never actually going to change the data type in the introduction class, unless we have to, we might do a little something with an integer, but just something to be aware of. Now, if for some odd reason you said, hey, this start button's the wrong one, right? That's saying it's 0.0. That's saying it's over here, where my start button is actually B0, so it's 1.0. So you can just come in here, and you can drop this down, and you can say, oh, this is 1.0. And notice it yells at you that this address is already used by another tag, and it actually highlights them both in yellow. So it does bring that to your attention. Is this a problem? No. This is a warning. All right, you can use both tag names. It'll reference the same input. It won't affect anything poorly. However, most people don't have a need to have the same tag, the same input address, have two different tag names. It will cause confusion in your code. So I highly suggest not having any of these yellow tags going on. In your inputs and outputs, it won't be so much of an issue. In your memory, if you're creating more bits and you forget which ones have and haven't been used, that's when it's probably going to cause some problems for you. So. But anyway, I like to fix that right away. So I'm going to call my first three. I'm just going to drag that down. I'm going to overwrite just those. Now it yells at me there's 3 issues. And I'm going to start this back at 0.0. And I'm going to drag, I got to make it I0.0, sorry. It's I0.0. So you can just type them in. And I'm going to drag that down. So all of my inputs, I've got one over. I don't need input 9, so I'm just going to delete that one. So all of my limit switches are going to be my first bank, and then my buttons are the second bank where they actually are. Now, we are in the inputs. If we would go to the outputs one, you could do the same thing here. So you could do like conveyor forward. And now you will realize that it defaults to address 1.3. So we want to make this output, so that's going to be Q. And again, we're going to start at 0.0, most likely. If you can create your tags first, then do your wiring, or you can do your wiring and then create your tags. Just make sure that the tag name and the address actually line up. That's going to be very important for you. All right, and then again, you could conveyor forward, do conveyor reverse, maybe a punch mechanism, and then a drill mechanism, and then a siren, or whatever the case. And notice again, the addresses just keep incrementing. This is why I like creating my tags first and then doing the wiring, but you can change them after the fact. You could always come back through and just flip to if you have them backwards. Like, oh, conveyor forward and backwards or reverse. Just, come in here, make that as 1, and then make this a 0, and everything's honky-dory. So that is very, very nice in the long run. So far when we've talked about these tags, we've talked about physical, real-world things, because the inputs were this top row up here, the outputs are down here at the bottom. Then what is memory? Well, memory is a fake input-output. All right, it is a place for you to store a piece of information, and that piece of information could be that a piece has gone past a sensor. You could have that. It could be that you want to keep the system engaged, a virtual start enable light type of thing. Memory is there for it to remember something. That's why it's called memory. This could be, again, a Boolean, or it could be a different data type. For our purposes, again, Boolean is the data type that we want to be using for basically everything in the introduction class. But that is very important for you to have those memory bits to remember that there's a piece on the conveyor belt and the conveyor belt should keep running. So we'll come back to those memory bits later in the semester as we start getting a bit more complicated in the code. But those memory bits are very, very important. Anyway, that is kind of a quick review of the inputs, outputs, and memory. I guess I'll just create one saying part on conveyor. All right, and then I'm going to make this a memory. Now, the clock bits, if you remember correctly, clock and system, those used memories 0 and 1 if we come back to that default tag table. So we don't want to use 0 or 1. I like to just pick a random memory bit to start. I'm going to call it M10.0. And that way, anything that I add in here, so I could say, part left conveyor. I don't know why you'd want that, but hey, you can do it. Now, notice again, it increments automatically. If you create a tag from the program area, it will not necessarily follow this. It'll find the lowest memory bit that's not used and use that one. But if you're in the tag tables, it will continue to follow that. Once you get through done 10, it will go to 11 and then 12, etc., etc. So that is my personal opinion on the memories and just picking a number and starting with it. And maybe even in your memory tag name over here, you're going to say this is memory, 10 to 15 or something like that. So that way those bits are reserved for you in that section. So. All right, that's all I've got for the tags. The next video, we will be talking about actually programming.